Hello and welcome to the third video in the Cambridge National Award Certificate in Systems and Control Engineering R113 Electronic Principles. On the last video we left you with a question. We were practicing our use of Ohm's law. And you were left with the question about this limiting resistor, and we talked about how the 6 volts, the potential is shared across all of the components. In this situation we've got 3 volts at 0.03 amps, and we have here 3 volts because that's what's going to be left. There's going to be 3 volts here and 3 volts here. The total potential drop in a circuit has to add up to 6 volts. Well, 3 plus 3 would be 6. So the question then was, what would be the resistor that we require to protect this blue LED? So I'm looking for resistance R being the voltage divided by the current. We've got 3 volts. We're looking for a current of 0.03. And so 3 and 3 go 1. 1 decimal place, 2 decimal places, going to be 100 ohms. So I would need a resistor of 100 ohms to limit the voltage and current to protect this blue LED. Now, what's interesting about resistors is that I could have 100 R, or I could actually have 2. I could do it like this, because I've got off the bottom of the page nearly there. If I had 50 ohms there and 50 ohms there, quite simply the total resistance is simply the R1, so we'll call that one R1, and call that one R2, is R1 plus R2. Doesn't matter how you do it, they can be like that. So that could be 300, and that could be 3K, which is the same as 3000. The total resistance would be 3300. And you can write that as 3K3, because the K, that's 3 point K, it's the same as 3000 ohms. The decimal place is often replaced by a K, so it's quite clear, 3.3K or 3300 ohms. So resistors, and we call this resistors in a series. So in series. That's quite a simple concept, and it's definitely one worth memorising, because you're likely to encounter this sort of simple question in the examination. Add the 2 resistor values together. Conversely, and more challenging, is the concept of resistors in parallel. And it could be this way, or it can go that way. And later on we'll be looking at, especially approaching A-level, where this arrangement sometimes can be presented with a series as well, to make questions a little bit more tricky for you. There's a formula for this, and it can be 1 or 2, or it could even be 3 or 4. R1, R2 and R3. Here we have R1 and R2. And the formula is that the resistance total is equal to 1 divided by 1 over R1 plus 1 over R2, and that continues. So I'll indicate that with 1 over Rn. So you just keep adding them. 1 divided by the resistor, and then R1, R2, R3, and when you've added those all together, you take 1 and you divide it by this value. Okay, so we'll have a look at an example of that. We'll go for something sort of reasonably simple. So we'll take a voltage and we'll drop it across these two resistors, like so. Now we're not working out the voltage. What we're looking at would be the total resistance. Let's just say that's 50, and we'll make that one 100. So in this situation, that would be 150 ohms. In this situation, it's a little bit different. What I can tell you is it's always going to be lower than the lowest resistor. Okay, so it's going to be less than 50 ohms. Okay, so I'm going to just sort of show that whatever it is, RT is going to be less than 50 ohms. Okay, you can sometimes imagine when we talked about water flowing, you can imagine that electricity is flowing through this point. This is quite a wide pipe, low resistance. This is quite a narrow pipe, it's higher resistance. But actually the two pipes combined together means that you've got less resistance. There's more ways for the water to flow. So it's going to be a lower resistance than the 50 because the 100 is going to contribute. So we do our equation. 1 divided by 50 plus 1 divided by 100 is going to give us our resistance total. So we'll pop our calculator in here. So 1 divided by 50, and I like to do this in stages, so I know that's 0.02. 1 divided by 100, I don't know what this is going to be. Okay, so if I add those together, I'm going to get 0.03. So 1 divided by 0.03, remembering that the answer should be less than the 50 ohms, yeah, that we talked about earlier. And we'll reveal that in the next video.